Concorde. It not only smashed through the sound barrier, but spent more time at supersonic speed than any other aircraft before or since. When the first passengers rocketed skywards in Concorde in 1976, it would mark the start of a new era of commercial air travel. For nearly 3 decades, the 14-strong fleet of Concordes remained the supersonic transport option of choice for the rich and famous. Captain Mike Bannister was Concorde's chief pilot at British Airways until the fleet was retired in 2003. Today, he's come to Brooklands Museum in Surrey, England, to see if he's still got what it takes to fly this extraordinary aircraft. Concorde was the result of a joint collaboration between Britain and France. And together, the two countries produced an aircraft with looks and performance like nothing else in the sky. Concorde pilots faced 6 months of intensive training before taking the controls of the real thing. Twice the time it took to master the Jumbo. This is what they trained on. Costing over $30 million in today's money, it's one of only 2 Concorde simulators ever built. A decade on from his last Concorde flight, Mike Bannister will now find out if he still has what it takes to fly faster than a speeding bullet.
And here we go. Now, we're going down the runway with full power, all 4 of our Olympus Rolls-Royce engines developing 38,000 pounds of thrust each, and the aircraft is very light.
To blast it through the sound barrier, Concorde needed a power plant capable of producing immense thrust. The Olympus 593 was the engine of choice, and Concorde had 4 of them. Ricky Bastion was one of the fleet's engineers. He knows the inner workings of these revolutionary engines better than anyone.
If you can imagine it like a giant vacuum cleaner, you've got a total of 14 compressor stages, gradually squeezing the air up as it comes in. Get to the center section here, where you get the combustion process. Air and fuel mixed and burnt, comes all the way out the propelling nozzle, getting hotter and hotter as you see. The various alloys get more exotic as you get towards the back end of the engine. So what you're doing is progressively squeezing the air up, bit at a time, and that's how you get a jet engine to work. It's, as we say, it's all a case of suck, squeeze, bang and blow.
Concorde's incredible performance remains unmatched. But designing an aircraft to fly at twice the speed of sound created a unique set of problems. Conventional aircraft are balanced in flight by adjusting control surfaces on the tailplane. But when operated, they generate drag, which slows them down. So Concorde used an ingenious system of pumps, which managed the aircraft's balance by transferring fuel to different tanks in the fuselage, tail and wings, allowing the crew to change the center of gravity without compromising performance.